Hi and Assalamualaikum everyone. Welcome to this chapter on multiple linear regression where we will dive into three methods for model selection: backward, forward, and stepwise selection. These techniques helps us refine our models by identifying the most significant predictors. So in this video, we will cover what multiple linear regression is and why model selection is crucial, and the backward selection method, the forward selection method, and finally the stepwise selection method. By the end of this video, you will have a solid understanding of how to apply these methods to your data. So multiple linear regression, it allows us to model the relationship between a dependent variable and multiple independent variables. But when we have many predictors, it is crucial to identify which ones really matter. That is where selection methods come in. Let's start with backward selection. This method begins with all potential predictors in the model. We then iteratively remove the least significant predictor one at a time until only the most impactful variables remain. It is a great way to simplify complex models while retaining the most important predictor. So basically, in the backward elimination, we start with all variables. All k regresses are entered into the model. Then we are going to calculate the partial F statistics for each predictor. The partial F statistics is actually measures the significance of each predictor in the context of other predictors in the model. And then we are going to compare the partial F statistics. The partial F statistics can be calculated as the expression here. And we are going to compare the calculated partial F statistics with the F out criterion. In backward elimination, we have these two criterion, F in and F out. However, in the case of backward elimination, we focus more on the F out, where typically we set this value at 4. So, coming back to the partial F statistics, after we compare with the F out, and then for each predictor, if the calculated partial F statistics is less than F out, is less than 4, therefore the predictor is considered to be removed or to be eliminated. And then after that, after removing a predictor, the model is refit and the process is repeated until all remaining predictors have F statistics greater than F out or greater than F4. Alright, let me take a few minutes to make sure you all understand how to calculate partial F statistics. So here, SSE full, SSE reduced, this is actually, let's say the first one, SSE reduced. This is a sum of square error for the reduced model, meaning that we exclude some predictor in this value. And then SSE full, this is a sum of square error for the full model, means that we have all predictors in the model. While backward selection is a useful method for simplifying a model by removing less significant predictors, there is another approach that works in the opposite direction, which is known as forward selection. So forward selection, it starts with no predictors in the model and gradually adds them one at a time. Each predictor is selected based on its statistical significance and contribution to improving the model. So this approach is basically effective when you want to identify the most impactful predictors without starting with a full model. So again, in this method, the regresses are added to the model one at a time until there is no remaining regresses. So let us see how this forward selection works. Before that, in forward selection, we also use a criterion similar to the F out in backward just now, but we use the F in. So basically the value is the same, F in and F out. We typically set it as 4. So let us see how this forward selection works. So the first to be selected into the model is the one that has largest simple correlation with the response variable y. And that is the first one to be entered into the model. And it must be greater than F in, which is equal to 4. Now, we already have the first variable included into the model. So what about the second variable? So the second variable to be added into the model it can be chosen by finding the largest partial F statistics. It is calculated by using this expression here. So if the largest partial F statistics is greater than F in, therefore that regressor will be added to the model. So the procedure will continue until there is no more predictor variables to be added into the model. So that's how forward selection method works. Finally, we have this stepwise regression, which is a combination of both backward and forward methods. It adds and removes predictors simultaneously, and it is the most widely used variable selection technique. So this stepwise procedure, it constructs a sequence of regression models by adding or removing variables at each step. So the criterion for adding or removing variables at any step is usually expressed in terms of a partial f-test. Let us see how this stepwise works. So it begins by forming a one-variable model using the regressor variable that has the highest correlation with the response variable y. In a similar way, this will also be the regressor that produced the largest F statistics. For example, suppose that in the first step, the regressor x1 has the highest correlation and it produced the largest F statistics, and therefore the first regressor x1 will be selected or included into the model. At the second step, the remaining regressor variable will be examined, and the variable for which the partial F statistics that we can calculate using this expression or formula is a maximum is added to the equation provided that its partial F statistics is greater than F in. Remember, our F in and F out is equal to 4. Suppose that in the second step, x2 should be added to the model. Remember, in our first step, x1 is already included or added into the model. Now, this is the difference between stepwise and backward and also forward. Because in stepwise regression technique, after we add the second regressor, we will determine whether the variable, the regressor x1 that is added in the first step should be removed or not. So this is done by calculating the F statistics as in this expression. And if the partial F statistics is less than F out, our F out is 4, the variable that is included in the first step, x1, will be removed. Otherwise, it is retained. And we would attempt to add a regressor to the model containing both x1 and x2 if it is retained. In general, at each step, the set of remaining regressor is examined and the regressor with the largest partial F statistics will be entered, provided that its value will exceed the F in, the partial F statistics. Then, the partial F statistics for each regressor in the model is calculated, and the regressor with the smallest observed value of partial F statistics is deleted if the observed partial F statistic is less than F out. So, this procedure will continue until we have no other regressors that can be added or to be removed from the model. I know this might be hard to follow without an example, right? So let's go through one example together. This will help you see how each method works. So here is the example. Consider a set of data with 3 regressors, x1, x2, and x3. The following are the analysis of variance table of the possible combinations of the regression coefficient. Based on the ANOVA tables, perform stepwise regression, forward selection, and backward elimination to find the final appropriate regression reduced model of the data. Alright everyone, moving on to the solution for forward selection. So in forward selection, we start with one variable. This is the difference between forward and backward, where in backward, we start with a full model, include all the predictors. So basically, forward selection we also mention as in process. So the first step is we need to look at the highest F statistics for each regressor, for each predictor. So what do we have here? The highest F statistics is 53. This is for x1. So this means that the variable with the highest f value will be included in the model at the first step. So we have x1 to be entered or to be added into the model. So now our model contains only x1. So the next step, we want to determine which variable to be added in the next step. So we should find, or we have to find, the partial f statistics with the x1 is already in the model. Okay, we want to see the effect of f2 and also x3. So we find we calculate the partial f statistics using the formula just now. You can also use SSE. Okay, so this is SSR for the full model. All right, and then minus sum of square regression or SSR for the reduced model. So what do we have here? Look at here. This is greater than 4. Remember our criterion? This is less than 4. So meaning that since this partial f statistics is greater than 4 for this x2, so now x2 will be entered into the model. Now our model become y equals to x1 plus x2. So we have these two regresses in our model. But wait, we are not finished yet. So we're going to check for x3 given that x1 and x2 is already in the model. So as usual, you find the partial f statistics. So what do we have here? The answer is 0.2857, which is less than the criterion value, which is 4. So what is our decision? X3 cannot be added into the model because the partial f statistics is less than 4. So our model remain as the model contains x1 and also x2. So our best model using forward selection is y equals to, you can write the full model here. So we have similar answer by using forward and also backward. So here we come to the last selection method, which is stepwise. So if you remember, in stepwise, we actually combine both forward and also backward. So in stepwise method, the first step to start this procedure is actually exactly the same with the forward selection. We begin, or we start with no predictor in the model, and we're gonna add the most significant predictor first. So how we are going to determine which one is the most significant is by looking at the f statistics for each predictor here, the highest f statistics. So what do we have here? We have the f statistic, the largest f statistic is actually for x1. So it means that the first regressor or the first variable to be entered or to be added into the model is x1. So now the next step is to add the next best predictor. So we're going to calculate the f statistics, given that we have the x1 in the model based on the first step. So we're going to calculate the effect of x3 when we have x1, the effect of x2 when we have x1 in the model. So we're going to find the partial f statistics, and also don't forget we are going to use our criterion, which is 4, f in and f out. So f in and f out is just the same, we set at 4. So what do we have here? So we have the value of partial f statistics here. This is less than 4, this is greater than 4. So what should we add in the model? It is x2. So now in our model we have x1 and x2. But remember, if we are doing stepwise selection, because we combine both forward and backward, so each time we're doing this, after each addition of a predictor, we will also check if any of the already, the included predictor just now, it become non-significant. So we now gonna check whether we should remove or retain them. So we should check after we include the x2, so is whether the x1 is still significant or not. That is why we find, or we calculate, we compute the partial f statistics here. So what do we see here? What can we see here? We have the partial f statistics that is greater than 4, meaning that the effect of x1 is still significant even though we have included the x2 in the model. So now our model is still the same, x1 and x2. Now we are going to check, given that in our model we have that x1 and x2, so what about if we add x3? So now we calculate the partial f statistics, and the answer here we have 0.2857 less than 4. So the conclusion here, our decision here, we cannot add the x3, so our model remain as y with that two regresses x1 and x2. So the best model using stepwise is contain only x1 and x2. So we have similar solution if you are using stepwise. Based on this example, we have similar solution if you're using stepwise, forward, and also backward. So in summary, selecting the right predictors in multiple linear regression is actually so important for creating accurate model. So whether you use backward, forward, or stepwise selection, each method actually offers a unique approach.